Hi guys, this is Mohammad P at tutor on Chegg.com. Today we are talking about evaluating integrals and some techniques about that. So we have few techniques that helps you to calculate and evaluate integrals. So the first one that we are going to talk about is changing the lower and upper limit and what is the result if we do that. Okay, so let's say you have integral from a to b of f of x dx. And if you want to write it as a b to a f of x dx. So what happens to this? Are these equal or not? So basically, we want to somehow relate these two together. So you can set them equal if you assign a negative value to them. So basically, this property says that if you switch the lower and upper limit of integration, there would be a negative multiplied by the integral. For example, if I calculate the integral from 0 to, not 0, let's say 1 to 2 of x dx, so that's basically x squared over 2 from 1 to 2, that's 2 squared, which is 4 over 2, minus 1 squared over 2, which is 1/2. So it gives me 3 over 2. Now let's see if I calculate the limit, the lower limit 2 and the upper limit 1 of x dx. So obviously the result of the antiderivative is going to be the same, but it's going to be 2 to 1. And as you see, so you are changing the order of the subtraction here. So you have 1 over 2 minus 4 over 2, which is negative 3 over 2. And this negative is actually coming from switching the limit of integration, because you are changing the order here in this subtraction. So the first property is when you have the integral and you want to switch the lower and upper limits, you multiply it by extra negative. So the second property that it's useful to evaluate integral is the integral of a to b of f of x dx is equal to 0 if a is equal to b. So this is helpful, like if we have a case integral 2 to 2 sine x e to the x times x plus 5 dx. So they are giving you like an integral which looks really hard and difficult to calculate, but it's a little bit, it's just tricky. They are trying to trick you. They are giving you like the upper and lower limit equal to each other. Basically, when you have these two equal, it means that the x is not changing at all. So when x is not changing, so the result of the integral must be 0, because we are talking about the change in x, and when it's not changing, obviously the limit of integral, the result of the integral is going to be 0. So that's another property that you need to know, and that's very useful. Okay. Another property that you need to know is when you have integral of a to c of f of x dx, this can be broken down to the more integral if you're breaking down to the more interval. So I can write it a to b f of x dx plus b to c f of x dx. So I can write one integral in terms of two other integrals, but the only conditions is that the b must be a number between a and c. That's really helpful to know, because sometimes they're giving you like two of these integrals and asking for the other ones, and you need to know how to set up the order. So the order is that when you have a larger interval like a to c, and you choose a number b between them, the order of the integrals is going to be like this. A to b, you cover first this integral from a to b, and then you add it to the integral from b to c, and then you get the whole integral on the interval of a to c. So that's another property that you need to know. Another one that I can actually recommend you to know is when you have integral negative a to a of f of x dx. This is going to be 0 if f of x is an odd function. So what do I mean by odd function? Odd function is a function that is totally symmetric about the origin. For example, like this one. Whatever you have here, you have the same thing with respect to the origin. So if you flip it with respect to the origin, you would get the same thing. Like the function y equal x cubed. For example, the integral of negative 1 to 1 of x cubed dx, without calculating, you can say that's equal to 0. So whenever the lower bound and the upper bound are basically symmetric, like they're the same but opposite, then you can, and the function is odd, then you can say the result of the integration is 0. And the very last thing that I need to go over, if you have the same situation and your f of x is even, this is even function. Even function means that it's symmetric about the y-axis, like this. Y equal x squared. Then this is equivalent to 2, 0 to a f of x dx. This helps you to actually reduce the amount of the work when you're calculating the integral, because dealing with the 0 is basically faster and easier for all of us. So whenever your function is even and the lower and upper limit of the integrations are the same and opposite in sign, then you can actually write from 0 to a and then multiply by 2. And that's because that's true because whatever you get for the negative a to 0, you would get the same thing in terms of area from 0 to a. That's also true for the odd function. If you look at here, whatever I get from negative a to 0, that's basically negative, and it's equal to the same thing for what I get from 0 to a. This is positive, and these two cancel out each other. That's why I get 0 here. So in the odd case, they cancel out and you get 0. In the even case, they add it up and you get the double of the integration from 0 to a. So I hope that you all enjoyed, and until the next video, have a wonderful day. Goodbye.